Cockroach eggs? No thanks. This is what I came for. Induction stuffs are generally a good source of lit wire. This is how much I got out of this one, and it'll be put to good use shortly. Remember the idea I was talking about? I wanted to coat the rails in solder and then heat them to melting point so I could have a liquid metal interface, or at least one less toxic than mercury. My first attempts involved using a power resistor to heat the rails, but then I killed about four of them. I did get the solder to melt, but the power dissipation was too much for the resistors to handle. The fact that power resistors are just small resistors in a ceramic case might have something to do with this. So I broke out my old soldering iron in hopes of using its heater, but all I found was this thin wire that had an unusual resistance. I clipped my power supply to a small length of the wire and held it taut. This setup produces enough heat to melt flux but not solder. Next, I tried tying the ends of the wire to a couple of pin tails for better electrical contact and put it on a breadboard. Only by increasing the voltage and therefore current, I was able to get the wire to heat up significantly. Even now, it was really sensitive to air currents, losing its glow even if I blew on it. By increasing the current to around 500 milliamps, I was able to get a nice steady glow that was less sensitive to air currents but was still extinguishable by blowing air on it. Above this point, increasing the current resulted in thermal expansion and slack, and I was afraid of melting the wire. I tried melting some solder, but that just resulted in the wire breaking. At this point, I got a little bored and decided to test a wire to destruction. I tried a few pieces in parallel. Heating was uneven because of bad contact, but this time I was able to melt solder. I know this was a stupid idea, but I tried heating a rail with just a single wire and failed miserably. Luckily, I had an old 936 rip-off which I took apart and extracted the heating element from. The wire was a lot thicker, and this time the results were more promising. After carefully removing the burnt flux and other slag from the surface, I was left with a nice shiny layer of liquid solder. The phenolic stood up to the heating quite well. None of this black stuff is conductive. As expected, the rails take quite a while to cool down. I managed to secure a couple of soldering iron heating elements from a friend and proceeded to take them apart with a little difficulty. Inside them was a lot of white sand, which may have been the remains of a ceramic core. I was able to pull out the heating wire and the core it was wound around. Of course, the wire is useless to me since it's too thin, but I think I can use the cores with the thicker wire as rail heaters. Speaking of rails, processing them to use with the heaters is quite the task. Solder must be kept away from the tabs, or it would be impossible to fit them into the plates that hold them together. Solving this problem is quite time intensive. The rails have to be sanded and taped, the outline is cut out, and the region to be soldered on is masked. After this, the rails are dipped in a solution of copper sulfate. After a day, the part of the rail that was not masked develops a coating of some sort. I don't know exactly what's going on here, but I suspect it's some kind of an electrochemical reaction. Then it's time to solder. The tape peels off quite easily, exposing fresh copper. The oxide layer formed on the other parts keeps solder confined to the exposed strip. I had to resist the temptation to add too much solder since any leaks would mean that I had to start all over again. The most important step in this whole process is to wash off the excess flux, preferably when still warm, since the flux could eat away the oxide on future heating and let solder flow where it's not supposed to. And once all of that is done, I am left with a usable rail. Finally, I waited almost a year and a half for this. Since the slots are rounded, it takes a little sanding and carving to get the rails to fit. To remove the copper from the phenolic, I make the usual solution, 50% vinegar and 50% peroxide. Drop the phenolic in and add salt to taste. The end results look like this. After a little screwing, the railgun in its new shell is ready. Though my choice of phenolic was an independent one, it's supported by Fred Beach, who is now the assistant program manager for the US Navy Railgun. And now it's time to start earnest work on the actual gun. I've got to clear the table, of course, and while we are at it, I have a new set of PCBs on the way. The first order of business is to clean up the current setup consisting of the PCBs on a crude acrylic frame. The handle is not attached, only the charge and trigger switches are connected through unnecessarily long wires. This was in the hope that I could clamp the frame to the bench and remote fire it, hence the long wires. Now plans have changed. Everything here was soldered using wires of arbitrary length, and that made the disassembly more difficult. So the first thing to try and do was to attach the handle to the frame through a couple of hooks that hooked onto the screw posts in the handle. The next thing was to shorten and trim the wires, attach the charged micro switch and power it up to see if everything still worked, which it did luckily. To tidy up the wires, I used a zip tie, and then the other half of the handle goes on. It takes a little effort to stuff everything into it so the halves can snap together. After it's done, I feel the railgun pistol for the first time. It's comfortable because it's a Nerf gun handle after all. It's also got good weight to it. In go the stock screws so that the handle does not fall apart. Now for the railgun. This pair of rails is the best I have and it would do good to get rid of that muzzle shunt. A few final touches and it's ready. Ladies and gentlemen, I present to you the world's first railgun pistol. Of course, that's only half the story. I still have to power this thing up and luckily it works. I tried to charge the caps but it took too long so I panicked and turned the supply off. I forgot that I changed the feedback resistor for testing and that slowed the thing down. I remembered this and tried another charging cycle. The caps overshot a little but that's okay. Now I have to get rid of the stranded wire so that I can replace it with the lids wire. The lids wire refused to be tinned, whatever I did, and I spent a couple of days breaking my head over the matter till I decided to sand it. And I found out that it was aluminium. And that is where things came crashing to a halt. There's nothing I can do till I find some copper lids wire, so till then, I guess.